Hello everyone, I am Surabhi. Before getting started with the course, quickly take the pre-test. Hello everyone, welcome to the second module of Power System Basics, Earthing. Hope you have understood the concepts discussed in Module 1. Eager to learn more about earthing? Let's get started. Take a look at the objectives of this module. By the end of this module, you will be able to describe the method of testing earthing resistance, describe the design and application considerations for earthing, list the Indian standard rules specified for earthing, explain about the maintenance of earthing pits, list the dimensions required for deep bore earthing, discuss earthing design considerations in HT transmission line, list the specifications for tower earthing, identify the features of lightning arresters, list the precautionary measures for earthing of lightning arresters. So, let us get started with the first topic. We have already learned some terms associated with earthing in the first module. Are a few more. Click on each tab to learn about them. Earthing mat is a grounding system formed by a grid of horizontally buried conductors which serves to dissipate the earth fault current to earth and also as an equipotential bonding conductor system. As you can see, the grid has conductors and the galvanized iron wire or GI wire connects the mat to the installation above the earth's surface. This is what an earthing mat looks like. If the coefficient of earthing is less than 80%, it is called effective earthing. The ratio of root mean square or RMS value of line-to-line voltage to that of line-to-phase voltage should not be more than 80%. The resistance to earth of an electrode of given dimensions is dependent on the electrical resistivity of the soil in which it is installed. It varies within extremely wide limits between 1 to 10,000 ohm meter. Did you know that the soil resistivity depends on soil type and differs from soil to soil? Yes. Here is a table with the figures of resistivity for different types of soil. Take a look. You can also download this table for reference by clicking the PDF icon on screen. Our next topic is about earthing resistance. We have learned about soil resistivity in the previous screen. Now let us see what is earthing resistance all about. As you know, earthing resistance is the resistance of the conductor that leads the fault current to earth. Earth resistance includes resistance of electrodes, contact resistance between soil and electrode, and resistance of soil or soil resistivity. But how do we determine which is the right place for earthing? And what are the other things to be kept in mind before going for earthing? Let us discuss in the next topic. This topic is going to be really interesting. We have discussed so many things about earthing, but how do we determine which place is fit or what are the other technicalities to be considered before providing an earthing connection? Let us see. So, once you decide that an earthing connection has to be given, these are the points that need to be considered. The selection of conductor, the selection of point where the conductor is to be earthed, the selection of size of earth wire, lead arrangement, protection, and mode of connection to the earth electrodes. The selection of earth electrodes and the limitation of their resistances to the ground. Fault current of the system and location of earthing station. Let us now look at a few more key points to consider when going for an earthing connection. They are selecting a suitable site, checking the extent of moisture therein, and checking the presence of suitable salts. Click on each image to learn more. A site shall be so chosen that is not naturally well drained. Water should not be flowing over it. If an imported fill exercise has been carried out, in these cases, deeper driving of the electrodes may be necessary to reach layers. The normal moisture content of soil ranges from 10% in dry seasons to 35% in wet seasons, and approximate average may be 16 to 18%. To reduce soil resistivity, it is necessary to dissolve in the mixture normally contained in the soil some substance which is highly conductive in its water solution. The most commonly used substance is common salt, mixed with fine sand in suitable proportion. Now something about earthing connections. There are some specifications for the earthing wire and connections as well. So firstly, the earth wire and connections should be mechanically strong. Next, you all know that electrical equipment are connected to earth using two types of conductors, naked wires and insulated wires. So for earthing, insulated wires should be used as earth lead for system earthing, and their voltage grade is determined by the earthing type. If it is solid earth, then the insulation should have a rating of 1100 volts. If it is resistance earthing, then the insulation should have a rating of 1/3 of the system voltage. Let us move on to learn a little more about earth wire and connection. Let us now see what kind of connections are used for different types of earthing. Click on each tab to learn more. For equipment earthing, galvanized steel flat bar or mild steel rod shall be used as earth lead and painted with green or yellow as specified by IS 3043. Flat shall be connected with nut and bolts and welded connection for rod. In case of system earthing, earth lead shall be mechanically protected by providing Hume pipe throughout its length when it starts from transformer cell. We have already discussed about earth electrode. Let us see if you remember it. Read the question, select the correct option and submit it. Well, so Mayank, we have already discussed about earth electrode. Let us see if you remember it. Read the question, select the correct option and submit it. Well, so the purpose of having an earth electrode is that it shall be able to resist corrosion for long time. I think we should have Mayank here for this topic. Ah, here he is. Hi Mayank.
Hello, Surbhi. Yes, how can I help you?
Mayank, we were discussing about earth electrode and its purpose and specifications. So, thought you could help.
Sure. So, Surbhi, we all know about earth electrodes. It is used in earthing as it is able to resist corrosion for long time. Also, the recommended material is galvanized steel for pipe electrode and cast iron for plate electrode. So, as you can see, this diagram is of a pipe earthing pit. The pipe that you see here are galvanized steel pipes.
Okay, but Mayank, what are the numbers for?
Yes, coming to that. Firstly, this diagram shows two similar pits, that is, both of them are either earthing equipment pits or neutral pits. The important thing to observe here is that, in case of similar pits, the distance between both the pits will be more or equal to 2000 millimeters. However, in case of two dissimilar pits, that is, if one is neutral pit and the other is an equipment pit, then the distance between both pits will be greater than or equal to 4000 millimeters.
I see.
The other numbers refer to the size of electrodes. They will be 40 mm nominal bore galvanized steel pipe, medium duty conforming IS 1239, stock number 123 by 0112, and of 3500 mm minimum length.
Great.
As mentioned earlier, recommended material for plate electrode is cast iron. This diagram shows a cast iron plate for plate earthing. Also, size of plate electrode shall be 600 by 600 by 20 mm. For copper plate, the thickness shall be 10 mm.
That was informative. Stay with us, Mayank, as I have another question.
Sure, Surbhi.
So, Mayank, we have seen the different dimensions for different pits, but how do we differentiate the pits? Is there any way to do that?
Sure, there is. Previously, we have seen the dimensions of earthing pits required when they are constructed. So after construction, earthing pits are provided with identification plates. It looks like this, and these are the required fields. These identification plates have the following dimensions. For neutral earthing, the size should be 300 by 220 mm and painted with red background for neutral earthing station and black background for equipment earthing.
Now I get it. That really helped. Thanks, Mayank.
Anytime.
Wow, this is getting interesting. We have discussed so many things about earthing. But have you ever thought who governs and specifies the rules or standards? Yes, all these earthing related specifications are done as per Indian standards. There are quite a few set standards that need to be followed regarding installation of earthing pit. Let us take a look at them. Distance between equipment earthing pit and system earthing pit shall be at least 4 meters. As you can see here, this image shows two different earthing pits, red one being a system earthing pit and the black one an equipment earthing pit. If different pits are required in same location, then they should be installed 4 meters apart from each other. Similarly, the distance between two similar pits, for example, two equipment earthing pits or two system earthing pits, should be 2 meters. For outdoor substation of 33 kV and above, the earthing grid or mat shall be provided. The earthing grid or mat shall be located inside fence for the substation. Fence should also be earthed separately. Earthing station area shall be barricaded suitably by means of wire mesh fencing and it shall be earthed separately. The door and fencing should be earthed. Height of wire mesh fencing shall be 1.2 meters. In case barricading is not possible, a feeder pillar box of suitable size may be used to protect the earthing pit. Such unbarricaded earthing pit shall be at least 1.2 meter away from the road. So these are the rules for installing earthing pits. Now, we shall look at how system earth and equipment earth are interconnected. And obviously, we would need Mayank's expertise to understand this better. Let's welcome him once again. Hi Mayank, please help us understand the connection between system earth and equipment earth.
I will be glad to explain. We will understand this through an animation. Let us say this is an equipment pit wherein the non-current carrying parts are grounded. You can also see that there is a neutral bus bar and further, there is a neutral pit. Here, we can see that the live part is grounded. Now suppose there is some maintenance work or testing to be carried out near neutral earth pit, suppose pit B. So, since it is connected with the live part, the testing or maintenance cannot be done online. This connection needs to be isolated first. However, isolating it will destabilize the power system.
Oh, then?
Therefore, before putting off switch B to disconnect the power, we will put on switch A first and then put off switch B. Doing this will cause the neutral of the transformer to connect with the mass of earth through the equipment bus bar. This will allow the power to be disconnected to pit B without disturbing power to the installation and work can be carried out. This is all about the connection between system earth and equipment earth.
That was indeed interesting. Thank you.
Pleasure is all mine.
Let us further learn about maintenance of earth pits. In the process of maintenance of earth pits, the first step is commissioning. Let us look at what are the steps that need to be followed in commissioning. Before commissioning earthing pits, it shall be filled with a proportionate mixture of 50 kg common salt, 300 kg of water, and 1500 kg of soil. Ensure overall cleaning of earthing pit and earth system resistance should be measured by earth testing measure and the combined value should be less than 1 ohm. Let us move on to next step, that is inspection. In the inspection phase, all earthing systems shall be visually inspected before testing. This includes checking whether there is distinct earth pit for equipment and neutral earthing, checking whether two distinct leads have been terminated at the respective pits, ensuring overall cleaning, ensuring condition of earthing resistor and link thereof, checking the condition of earthing pit and masonry work, checking electrodes connection and their rigidity and the condition of earth electrodes above ground level. Once voltage is checked across earth electrode and earthing lead is found to be below 5 volt, testing is done. The next step is to test the resistance of earthing pit. It is advisable to test earth resistance during dry day, dry season in order to get conservative results. Further, records shall be maintained for the initial earthing resistance and subsequent earthing resistance. In this context, it is important to have a look at this table. The table here conveys how the resistance of earthing pit varies depending upon the seasonal condition. For example, if you take a look, the value of each month differ. While there is a lower value in July, January has a higher value. Therefore, you can see that the resistance values vary with the season. Also, if you look at the last row, the values have been consistently high in the month of January across all the 3 stations. Therefore, maintenance of each earth pit should be done when the resistance values are high. Further, this maintenance should be done during the dry seasons only, that is between January to March. So now we know that earth resistance varies season to season. Well, let us look at a few. So now we know that earth resistance varies from season to season. Well, let us look at a few more specifications in this context. Resistance should be measured during dry day and dry season. For low and medium voltage, it should be done in not less than once in 2 years. For high and extra high voltage, it should be done in not less than once a year. Identify the earthing station group to be tested. If resistance value is found high, that is over 1 ohm, then only individual station shall be tested. Test power in case of system earth. Caution tag shall be fixed at isolating point. Voltage shall be checked and this shall be within 5 volts. Only insulated lead should be used. The lead should be as short as possible. Current electrode shall be placed at least 30 meters away from earthing station and potential electrode midway between them. Auxiliary electrode, usually consisting of 12.5 mm diameter, mild steel rod, shall be driven into the ground up to depth of 1 meter. The value of resistance to earth for each group of connected earthing pits shall not be more than 1 ohm for all range of voltages. Record of such test should be maintained for future reference. Old value, which is written on the nameplate, should be replaced by new one. Let us now look at the process of how earth electrode resistance is measured. As you can see in this diagram, there is a megger. There is an electrical circuit inside the megger and outside it as well. The labels C1, P1, P2, C2 are all terminals of the megger. Whenever the handle of the megger moves, it generates some amount of DC voltage. This voltage, say 50 volts, depending upon the rating of the megger, is applied across the C and E terminals. This causes flow of current through the soil into the current coil of earth testing megger. Now the voltage is measured across E and P terminals by potential coil. The torque developed is proportional to V by I, which in turn gives the value of earth or soil resistance, and the current is passing through the soil. Depending on the soil resistivity, the megger senses the amount of current passing through the devices in terms of how much voltage is applied and how much current is going through the soil. So, to measure the earth resistance, the voltage generated needs to be divided by the amount of current passing through. This division will give an idea about earth resistance. Therefore, the megger is crucial in finding out the earth electrode resistance measurement. It is also referred to as earth testing megger. This is all about the earth resistance measurement process. We had learned earlier that testing should be carried out in the dry seasons only, right? Now let us now understand what needs to be done to maintain earthing resistance. Firstly, 3-4 buckets of water shall be poured in the month of January, March and November to keep soil wet. In case of high earth value, water shall be poured and resistance should be measured after 15 days of water pouring. If the earthing resistance is found consistently higher than prescribed value, then rework should be done. The periodicity of chemical treatment shall be determined by measurement of earth resistance based on routine test record. The adjacent area shall be clean, dry, and earthing pit should easily approachable. No material should be allowed to stack, dumped, accumulate, and debris shall not be deposited near or within the earthing station area. That was the end of this topic. Time now for a quick review. In the previous topics, we have learned about two types of earthing pits, pipe earthing pit and plate earthing pit. In this topic, we shall learn about another type, which is deep bore earthing pit. You know that earth pits are made to test earth electrode resistance and to find out the suitability of the area for earthing. When the testing is done, the required earth electrode resistance should be less than 1 ohm. Having too many pipe earthing pits and plate earthing pits may not give the required earth electrode resistance. Further, it is not feasible to have multiple earthing pits at one place since the area has to accommodate other equipments also. Therefore, the deep bore method is used preferably to reduce the number of earthing pits, especially in areas where soil resistivity is very high. Let us now look at the dimensions required for deep bore earthing. Bore holes for earth electrodes should be 550 mm bore diameter with length or depth ranging from approximately 10 meters to 20 meters. They are generally made by driving baler as indicated in the drawings for construction of bore holes along the boundary of the plant. The bore shall be abandoned and shall be shifted some other location at 2 meter apart in case of high value resistance. 100 mm diameter heavy duty GI pipe with holes at the bottom is centrally placed inside each of the bore hole and the area surrounded by GI pipe is filled up with good earth. All crane rails, cable trays shall be earthed by two separate and distinct connections to earth mat. Alternate building columns shall be connected to earth mats. Earth mats or grids shall be formed by properly routing 50 by 6 mm GI flats welded and secured duly along the structure, tunnel, building walls, etc. Please note that this type of earthing was adopted for earthing of electrical installations by the Stoor and Company in the Phase 2-3 modernization. Let us now move on to our next topic. Well, in this topic, we shall discuss about earthing for high-tension transmission lines. To understand about this, you need to look at the figure given here. As you can see, the earth conductor is placed on top of the structural tower or structure to provide a shield angle over the power conductors to protect against lightning stroke. The recommended angle being 30 degree with the vertical formation of power conductor. This is also called protection angle. The shield angle is usually maintained at 25 degree for outer conductor and 45 degree for central one. Let us move on to learn about the specifications for tower earthing. Let us now look at the specifications prescribed for tower earthing. Each 132 kV transmission tower leg to be provided with one single peg earth electrode as per TISCO standard 09032. The electrode length shall however be 3 meter with 18 hole of 10 mm diameter at the bottom, 1 meter as per TISCO DRG number EDA by 5980. The electrode ID shall be 38 mm and 3.25 mm thick. All the earth pegs of the tower shall be interconnected by 50 into 6 mm GI flat. Two diagonally opposite legs of the tower shall be connected to earth pit 50 by 6 mm GI flat. The connection of GI flat at tower leg shall be done at a height of minimum 50 mm from the ground level. Hope you remember these specifications. Let us continue to the next topic. Before talking about lightning arrestor, here are some amazing facts about lightning. Do you know that Earth is struck by lightning 100 times every second and 8.6 million strikes a day? New York's Empire State Building is hit by lightning between 23 to 100 times a year. It's amazing that thunderstorms also contribute to the creation of fixed nitrogen through rainfall and fertilizes plants and soil. Interestingly, the positive charges below cloud are more likely to hit tallest objects like treetop building. A single stroke of lightning is usually 4 to 6 km long and has speed of 160,000 km per second. A single flash may carry 100 million volt of electricity and temperature may reach 13,000 degrees centigrade, 5 times hotter than the surface of the sun. Unbelievable, isn't it? Well, so we have learned many amazing facts about lightning. Now, when we talk about electrical equipment earthing, it is important to learn how lightning affects these equipments and how do we prevent them from getting damaged. We know that all electrical power equipments have lightning arresters on them. They also need to be earthed. So, special precautions are needed for earthing of lightning arresters 132 kV and 33 kV fixed on the overhead lines. These are as given below. Connect earth terminal of surge monitor with earthing system. Erect 40 by 6 mm size GI earthing flat supporting insulators from lightning arresters earthing terminal and extend the same near surge monitor. Connect earth terminal of surge monitor to individual earth electrodes for each station type lightning arrestor, and the earthing flat should be straight as far as practicable. These earth electrodes should be connected to main earth system. Ground connection of surge monitor shall be made firmly before connecting the same near surge monitor. Well, we have completed all the topics in this module. Time now for a quick review. We have come to the end of the second and last module of Power System Basics Earthing. Here is a quick recap of the key points discussed in this module. In this module, we have learned that earthing resistance is the resistance of the conductor that leads the fault current to earth. There are set Indian standard rules for earthing and installation of earthing pits. The process of installing earth pits involves commissioning, inspection, and testing earth pit resistance and maintenance. Earth resistance testing should be done only in dry seasons. Another method of deep bore earthing is used, preferably to reduce the number of earthing pits, especially in areas where soil resistivity is very high. There are rules specified for a HT transmission line earthing, tar earthing, and for earthing of lightning arresters as well. Thank you for your time. Hope you enjoyed learning. Click Next to take the post test.